2022年第35、36條呢係有關於科學探究嘅。今次呢，我哋想探究嘅議題呢就係有關於滲透作用啦。咁我哋有兩條唔同長度嘅透析管 （dialysis tubing） 透析管，咁入面呢就係載住2% 嘅蔗糖溶液嘅，而佢哋呢都係分別浸咗喺一個10% 嘅蔗糖溶液入面。咁整個實驗呢，我哋都係擺喺25度攝氏呢去進行嘅。咁呢個題目呢就問啦，咁下面 A、B、C、D 邊一幅圖呢係能夠正確顯示得到喺呢個透析管上面嘅呢一條微管呢，呢個液面位置嘅改變啦。咁成條題目呢就考緊我哋幾樣嘢嘅。第一啦，就係滲透嘅定義啦。咁記得翻啦，滲透嘅定義呢就淨係講水分子嘅正向移動，由邊度去邊度啊？就係由一個高水勢嘅位置去到一個低水勢嘅位置，而過程當中呢，呢啲水分子係會經過一個差異滲透嘅膜嘅。咁之後啦，再考我哋嘅呢就係有關於呢個實驗啦，裝置1、裝置2水分子嘅正向移動嘅方向究竟係如何呢？再加埋啦，由於呢兩條嘅透析管呢，佢哋嘅長度係唔同嘅，咁自不然就係考翻我哋啦。有咩嘅因素？今次我哋研究嘅就係表面面積啦，點樣影響得到滲透嘅速率啦？咁當中呢，有一個好重要嘅概念，大家一定要識嘅，就係記得翻啦。一個溶液嘅濃度越高，佢嘅水勢呢係越低嘅。濃度越高，水勢越低。嗱，呢個呢，大家唸口黃都要記得㗎啦。所以當初我哋學過㗎嘛，蒸餾水就係最低濃度啊嘛，因為0啊嘛，乜都冇啊嘛，淨係得水分子啫嘛。佢嘅水勢係最高嘅。好，咁而家啦，睇翻題目咯。咁而家啦就睇一睇題目4幅圖咯。成個思考邏輯呢，第一我哋就要知道翻水分子嘅正向移動嘅方向啦。咁頭先我哋都已經知道咗㗎啦。原來啦，濃度越高，水勢係越低，同埋啦，滲透嘅定義就係啲水分子由一個高水勢嘅地方去到一個低水勢嘅地方，而當中啦係要穿過一個差異滲透嘅膜嘅。而今次透析管就係呢個情況啦。咁而家我哋發現啦，喺個透析管入面呢，就係2% 嘅蔗糖溶液。咁出面呢就係10% 喎，咁自不然啦。喺呢個透析管入面嘅溶液呢，佢有一個高一啲嘅水勢啦，係嘛 higher 嘅 water potential 啦。咁呢個 R 叉呢就係 water potential 啊嘛。咁對比翻啦，10% 嘅蔗糖溶液呢，佢有一個低一啲嘅水勢咯。咁所以啦，由於入面係高，出面係低，畫翻個三角形啦。咁自不然啦，就係呢由高去低啦。所以啦，無論係短嗰支管定係長嗰支管呢，其實嗰啲水分子都係正向地離開咗我哋嘅透析管嘅。咁離開咗之後啦，第二個問題咯，咦？咁楞住個透析管嘅嗰條微管啊，呢個液體嘅水平啦，係會向上定向下呢？咁由於啲水分子而家係出咗去啊嘛，離開咗嗰個透析管啊嘛，咁先話入面係少咗水啦。咁自不然啦，呢兩個嘅液面呢，其實都應該係向下降嘅，所以都係下跌啦。所以嚟到第二步嘅思考邏輯呢，我哋已經知道㗎啦 ，C 同 D 可以 say goodbye 啦，因為呢兩個呢都係顯示咗個液面水平呢係上升喎，咁梗係已經係錯咗啦，係咪？好，咁答案叫糊㗎啦，一係 A 一係 B 啦。咁A 同 B 有咩分別呢？ A 呢個答案呢，就係裝置1，佢係跌得快一啲嘅；裝置2呢係跌得慢一啲嘅。相反啦 ，B 呢個答案呢，就係裝置2呢跌得快一啲嘅，即係話大家個液面水平都係跌㗎啦。不過一個跌快啲，一個跌慢啲。呢個就係我哋第3條題目要思考嘅邏輯啦。究竟邊個裝置佢有一個高一啲嘅滲透速率呢？呢兩條管最大嘅分別就係一長一短。咁其實啦，個邏輯就係講緊原來啦，一條長啲嘅管呢，佢有一個大一啲嘅表面面積去接觸住啲液體喎，係咪啊？呢個呢就係咁樣嘅表面面積，另一個呢就係一個長啲嘅表面面積喎，就係考翻我哋呢一個邏輯啦。原來啦，表面面積越大嘅時候呢，就會導致到滲透嘅速率都係增加。你話咦，梁 Sir 點解今次你寫擴散嘅？其實你要記得喎，擴散同埋滲透其實佢哋係一樣噶嘛，只不過啦，滲透之所以咁特別係因為佢淨係睇 水分子嘅喐動，同埋一定要有一個差異滲透嘅膜啫嘛。佢都係講緊高去低㗎，不過今次嘅高咧就唔係濃度嘅高，係水勢嘅高。咁所以啦，我哋能夠得出嘅結論咧，就係裝置2咧，由於佢條管係長一啲啦、大一啲啦，咁所以啦，佢嘅表面面積咧都係大一啲，所以答案咧就係 B 咯喎。2022 question 35 and 36 refer to the diagram below, which shows the setups used for investigating osmosis. Two test tubing of different lengths were filled with 2% sucrose solution and then submerged in the 10% sucrose solutions. And all solutions were kept at 25 degrees Celsius, and you can see the setup here. And the question is asking that which of the following graphs correctly shows the changes in the liquid levels of setups 1 and 2. So for the whole question is checking the several concepts. First of all, the definition of osmosis. Osmosis, it means that the net movement of water molecules across a differentially permeable membrane from a region of higher water potential to a region of lower water potential. And then we need to determine the net water movement in the setups 1 and 2. And it involves the very critical concept about the water potential and the concentration of the solution. The higher the concentration of the solution, the lower the water potential of the solution is. You can see that these two test tubing, they have different length. So this question also asks us to record any factor, for example, surface area, affect the rate of osmosis. So let's take a look at the thinking logic to deal with the question. The first question we need to think about is about the net movement of water molecules. What is the direction? So according to the definition of osmosis, the critical concept, we know that in the test tubing, they were filled with the 2% sucrose solution, and then for these two test tubing, they were submerged into the 10% sucrose solution. And according to the critical concept, the test tubing, it contains the 2% sucrose solution. They should have a higher water potential than the water potential of the 10% sucrose solution. The solution has a lower water potential. So we call that this symbol refer to the water potential. So if we know that in the test tubing, the water potential of the sucrose solution is higher than that of the 10% sucrose solution, so the net water movement will be moving out, leaving the test tubing. And after we have this idea, we need to think about the second question, the change in the liquid level. Will it rise or drop? So because the water, they are coming out of the test tubing, therefore the initial liquid level will also drop. By using these two questions, we can eliminate options C and D, because for these two answers, the liquid level, it rises, and it doesn't match our logic. And after that, for options A and B, which one is the correct answer? We need to determine which setup have a higher rate of osmosis, setup 1 or setup 2. So for options A, B, what is the difference? Is that for option A, the setup 1 it shows a higher rate of osmosis. And for the option B, it shows that for the setup 2, it has a higher rate of osmosis. So how can we know that which setup it should show a higher rate of osmosis? It depends on the length of the test tubing. And we can see that from this diagram, if the test tubing has a longer length, so there will be a larger surface area to keep contact with the 10% sucrose solution and for the osmosis to occur. Therefore, for the setup 2, it should has a higher rate of osmosis. Therefore, the answer is B.